Welcome back to our fifth video for Chapter 4, Effects of Electric Current. And today we're going to study something about simple motors. We'll also try to understand the difference between DC and AC motors. So we are trying to understand how a motor works. When a wire, that is this armature here, which is carrying electric current, which has its own magnetic field, is placed in the magnetic field of a magnet. Both the magnetic fields now are in direct contact, and as these lines of magnetic field are being cut, we realize that the coil is pushed outward. Okay, and this creates a motor effect. In order to understand how the motor will be pushed outwards, in which way the force is acting, how is the magnetic field moving, in which direction is the magnetic field, and also to understand the direction of the current, we use Fleming's left-hand rule. So let's understand what is this Fleming's left-hand rule. Now, if you take your left hand and place your three fingers, that is your thumb, your index finger, and the middle finger perpendicular to each other. Remember, each one has to be perpendicular to the other. So first the thumb is perpendicular to the index finger, and index finger in turn is perpendicular to the middle finger. So once you have placed your fingers in this fashion, let's understand what each finger is indicating. The thumb, when the thumb, index finger and the middle finger are stretched perpendicular to each other, the thumb indicates the direction in which the force is applied. The index finger points the direction of the magnetic field. Here you can see the direction of the magnetic field, which between the north and south pole, of course, there are straight currents flowing here. Straight magnetic field is generated, straight lines you can say. So the thumb indicates the direction of the force, the index finger represents the direction of magnetic field, and the middle finger shows us the direction of the current. So in short, you can remember TF, IM, MC. Thumb represents force, direction of force. Index finger represents the magnetic field or direction of the magnetic field, and the middle finger represents the direction of the electric current. Okay, so this Fleming's left-hand rule is basically used to predict the movement of the coil, to explain to you how the coil will rotate. The index finger is showing you the direction of the magnetic field from north to south. Second, that is the middle finger, is giving you the direction of electric current, this one. Okay, so you have the index finger pointing towards north-south, that is towards the direction of magnetic field. The middle finger is pointing towards the direction of the current, and the thumb is explaining to you the movement or the force, in which direction the force is applied on the coil, making it go in anti-clockwise direction or outward direction. Fine, so this shows you correctly here how the coil is. This is the coil which is placed. So this pen is representing the coil that is placed. The coil, if you see, is placed perpendicular to the lines of magnetic force. Okay, that is important to notice because it's cutting through the magnetic field. Later on, you'll understand why we need the cutting effect of magnetic fields. Now, Fleming's left-hand rule, in short, TF, IM, MC, thumb represents the direction of the force. It's not representing force, it's representing the direction of the force. Index finger, direction of the magnetic field, and the middle finger is showing you the direction of electric current. What is the practical application of this theory? Okay, the motor theory and this left-hand rule. By using the three components here, that is electricity, magnetism, and the movement, that is the motor effect. Okay, with the help of a coil of the electromagnet, a wide range of practical applications become possible. Electric motors have magnets, a coil, it has a magnet here, it has coil, and uses electricity in order to produce movement Basically, it is the magnetic field of the coil which is causing the coil to move in presence of another magnet and its magnetic field. So the magnetic field of the conductor coil pushes away from the magnetic field in the surrounding magnet, okay, thus turning the coil like a spindle. Once again, you can see this is a diagrammatic representation which is given in the books. Okay, so upwards force of the conductor, sideways direction of the magnetic field, and the other perpendicular finger, that's a middle finger, shows you the direction of electric current. So what is this electric motor and why do we call it as an electric motor? Now, electric motor is a device changing electrical energy into mechanical energy. Now, if you look at this shaft, this axle moving here, in case we attach an axle or a shaft like this, okay, a rod here, an axle, if we attach this to this particular split rings, we realize that the shaft will move, and if you place anything on the shaft, maybe a fan, okay, or maybe you can place a bulb which will rotate, okay, as the shaft rotates the bulb will also rotate, or maybe a piece of decoration during festivals like Ganpati festival, you normally make a fan move or a decoration move. Okay, now this movement is created by this electric device, okay, or this because of the electricity, which is of course inducing magnetic field and placed in magnetic field. As the coil is rotating, we are using this rotating movement, the motor movement, to make something else rotate on it. Therefore, this is called as an electric motor. Now, what is it using? It is changing electrical energy into mechanical energy. As the shaft is moving, the machine also moves. Okay, and it is used in many electrical gadgets like fans. Okay, the fan rotates because it is placed on this axle here or attached to the axle here, and along with this coil armature, this also rotates. So it can be used for pumps, it can be used in fridges, the compressors especially, the mixers, the computer, the washing machines, etc. all use this effect of electric motor. Right, so in the next video we'll study the construction of DC motors. Till then, take care and keep studying. Bye bye.